Okay, this is a grade 10 November 2015 question on stoichiometry or quantitative chemical change if you prefer. And remember, anytime you do this, you need to know all of your formulae for these calculations. And you also need to remember the most important thing to always do is find the moles. That is always step one, and the moles are always N. So it says to you, calcium carbonate reacts with dilute hydrochloric acid according to the following balanced equation. So this is one of those general reactions that you should know. A metal carbonate plus an acid goes to a salt, carbon dioxide, and water. Okay, so that is the general reaction for this. But the specific reaction here is calcium carbonate plus 2 hydrochloric acid, goes to calcium chloride plus carbon dioxide plus water. So it says this is an acid-base reaction. Define the term acid-base reaction. So acid-base reaction and redox reaction have similar definitions. A redox reaction is a reaction that involves the transfer of electrons. An acid-base reaction is a reaction that involves the transfer of protons. Remember, we're not talking about the proton that is in the middle of all atoms. We are talking about that, but we are talking about a hydrogen ion, which we also call a proton or a hydrogen ion. So this must be transferred between two different substances, this proton. Next year, you will learn more proper definitions for an acid-base reaction. So it says to you, the graph below shows the relationship between the volume of carbon dioxide and the mass of pure calcium carbonate. So once you see this word pure, you can be sure that at some stage there's going to be a percentage purity calculation. And the percentage purity is always given by the mass of the pure over the mass of the impure times 100 to turn it into a percent. Okay, so it says from the graph, determine the volume of carbon dioxide produced when 0,072 grams of pure calcium carbonate reacts. So we need to look in there somewhere. So let's see if I make this graph bigger. If we have a look here on this axis here, you can see between 0,06 and 0,08, 1, 2, 3, 4, 5 blockies will be 0,07, and then it'll be 2, 4, 6, 8. So now we are no longer in baby school. We must be very exact here. And so we will bring our ruler up to the graph on the exact line here. There's no margin for error here. Okay, so can you see there is the 0,072 line, and we want to see where is it going to meet the graph. The 0,07 is in the middle, so 0,072 is going to meet the graph over here, and then we're going to draw this line across the other side of the graph, and you will see that we are on, this is between 10 and 20, so every block is going to be 1, 2, 3, 4, 5, 6, 7, 8 blockies, so this one must be 18. Check your units very, very carefully. This is in cubic centimeters. So if we go back and answer the question, from the graph, determine the volume of carbon dioxide produced when 0,72 grams of pure calcium carbonate reacts, and no unit, no mark. It is 18 cubic centimeters. Remember, in all of these calculations, we also say the proper unit for doing these calculations is cubic decimeters. So you could give your answer in cubic decimeters, but because the graph is in cubic centimeters, they will probably accept the answer in cubic centimeters. But if we're doing calculations with this graph, we will have to do the conversion between cubic centimeters and cubic decimeters. Okay, now it says to you, a certain antacid tablet with a mass of 0,25 grams contains mainly calcium carbonate, which reacts with dilute hydrochloric acid in the stomach to produce carbon dioxide gas. So this is like a Rennies or an Enos. You know, if you drink Rennies or Enos, it makes you burp. What are you burping? You've made an acid-base reaction. You are burping out this carbon dioxide in the reaction. Okay. So it says to you, define the term concentration of a solution. Well, remember in your formulas, we have this formula that says C equals N over V. You can use this to help you remember it. Use the formula to help you remember it. Concentration is the number of moles of solute, okay, that is the N, yeah, per cubic decimeter of solution. Whoopsie, spelling decimeter wrong. Per cubic decimeter of solution. Sometimes they will let you get away with per unit volume, okay, but you can use the formula concentration equals N over V. It's the number of moles per unit volume or per cubic decimeter of solution. Okay, so now it says to you, it is found that 25 cubic centimeters of carbon dioxide gas is formed when one antacid tablet completely reacts. Use the information in the graph and calculate the percentage calcium carbonate in one antacid tablet. So from the question, when it said to you this is a reaction with pure calcium carbonate, and then they tell you that this tablet is mainly calcium carbonate, the rest is filler, because if you think about 0.25 grams, it's tiny, you're not going to be able to swallow that. So if this is your antacid tablet, inside your antacid tablet there will be little flecks of calcium carbonate mixed in with all of whatever the filler powder is. Okay, so this is the tablet that weighs 0.25 grams, and this is the calcium carbonate that reacts with the hydrochloric acid. Okay, so this is where the percentage purity calculation is going to come in, because they're asking you calculate the percentage calcium carbonate in one tablet. It's basically the percentage purity. So we need to know, like this formula shows you, the mass of the pure, and we need to know the mass of the impure. So we're going to get the mass of pure calcium carbonate off the graph, because it said to you this is the graph for pure calcium carbonate, and the mass of the impure is given in the question. It's the mass of the whole tablet. So this is going to be 0.25 on the bottom. That is the mass of the impure. So it says to you the concentration of the hydrochloric acid in the stomach is 0.1 moles per cubic decimeter. So if we go to, okay, so this is not given on the graph, but it tells you how much gas is released. Okay, but we might need this concentration in a minute. Okay, but it's told you how much gas is formed. From the amount of gas formed, we can get a mass of calcium carbonate off the graph. So if we go back to the graph, it said to you 25 cubic centimeters of carbon dioxide were produced. So we go 1, 2, 3, 4, 5. Okay, and then we draw our little line on the graph over here. That is the 25 cubic centimeter mark. And then we come down here and see what is on the other axis. If we come over here, we will see that basically this is lining up exactly on 0, whoopsie, that wasn't meant to move like that, 0.1. So that is giving me a mass of calcium carbonate per 25 cubic centimeters of carbon dioxide. So if we go back here, it says to use the information in the graph and calculate the percentage carbon dioxide. We worked out the mass of carbon dioxide that produces that much gas is 0.1 grams. So if you put this in your calculator, you will find it comes out to 40%. So we've got the pure from the graph, and we've got the impure from the question. Okay. Then it says to you, calculate the volume of hydrochloric acid that will be neutralized by one antacid tablet. So when we want to calculate the volume here, we're going to end up using, we know something about the hydrochloric acid, okay? It says to you the concentration of the hydrochloric acid is this. So we know that the C of the HCl, the concentration of the hydrochloric acid, is 0.1 moles per cubic decimeter. And they are asking you what is the V of the HCl, which means which formula connects the C and the V. It is C equals N over V, this formula over here. So somehow we need to find the number of moles of hydrochloric acid in order to answer this question. So that will be the end point, the volume of HCl. To get there, we need the number of moles of HCl, but everything in the question is giving you information about the calcium carbonate. So you know that whenever you do chemistry questions, step 1 is find the moles, okay, of what is given. Step 2 is to use the mole ratio. And where's the mole ratio from? It is from the coefficients of the balanced equation. And then you find the moles of what is asked, okay? And then the final step is to find exactly what is asked. And in this case, it is the volume. It asks you what is asked in this question is the volume of hydrochloric acid. So let's have a look and see what information we have here. Let's rub some of this out. So find the moles of what you are given. So at the moment it says to you 1 antacid tablet, okay? And we've just worked out that 1 antacid tablet is 40% pure, but in doing that, we read off the graph that 1 antacid tablet has got inside it a pure mass of calcium carbonate. Remember, we read it off as 0,1. The mass of pure calcium carbonate is 0,1. So now we need to convert this into moles. So we will use the formula, the number of moles of calcium carbonate is going to be equal to the mass of calcium carbonate over the molar mass. So to find the molar mass of calcium carbonate, we need to go to our periodic table. And if you look over here, we use the big number on the periodic table. We've got 40 for the calcium, there's 1 calcium, 12 for the 1 carbon, and the O3 says we've got 16 oxygens, so it's 16 times 3. So this ends up giving you the molar mass of calcium carbonate is 100 grams per mole. So we're going to put that big M on the graph over here, and little m is going to be 0,1 because that's what we worked out was in 1 antacid tablet. So this gives you 1 times 10 to the negative 3 moles of calcium carbonate. But the question didn't ask about calcium carbonate, it asked about hydrochloric acid. So we use the balanced equation and we use the coefficients of the balanced equation to find the relationship between calcium carbonate and hydrochloric acid. And it's 1 calcium carbonate to 2 hydrochloric acid according to the coefficients. So if we had 1 times 10 to the negative 3 moles of calcium carbonate, we will need double that in moles of hydrochloric acid to complete the reaction. So 2 times 1 is 2 times 10 to the negative 3 moles of hydrochloric acid. Okay, and now we are almost at the end. We are asked to be found because we've done step 1, find the moles. Step 2, use the mole ratio. And then to find step 3, what we are asked. And now we're going to turn it into the last part and we're going to use the concentration of hydrochloric acid is equal to the number of moles of hydrochloric acid over the volume. So the concentration of hydrochloric acid was given in the question. It's 0,1. It's equal to the number of moles, 2 times 10 to the negative 3, over the volume of hydrochloric acid. So if you put that over, you will end up 0,02 cubic decimeters of hydrochloric acid. And that is the final answer to the question.